data side by side in columns like this to be able to graph it like this, to use charts to graph it like that, okay? The same thing here. Now, let me show you this quote. Here is the graph for part 2. What we want you to do here, again, you've graphed the data. But then once you graph the data, I want you to, and all the instructions tell you this, I just want you to see it so you have an idea of what it all looks like. Here I have fitted a line, a trend line. This is a straight line. This is the exponential function, and in the instructions down here, if you read about the instructions are actually up in the body. But I tell you to use the exponential function. I tell you to look at all the functions, but in the end, choose the exponential function. Here's how you do that. Now, I'm using Excel for Mac, so this is a little different, but if you're doing it on a PC, you'll have basically the same functionality. You'll actually have more functionality. So I have highlighted my chart. Now I go up to chart design. I come over here to add chart element and click on that. And down at the bottom it says trend line. And notice here that I have several choices of different kinds of trend lines. What I'm telling you in the instructions, try some of these different trend lines and see how well they fit the data. You're looking for the one that gives you a line that seems to fit with the data the best. In the end, the exponential function fits it very well. You know, all of the data points are right on the function, except for this one at a price of 50 cents. It's off just a hair. But it's a very good fitting function. Okay? Then, down at the bottom of that is this menu item that says more trend line options. So if you click on that, then it gives you all of these over here. Now, in this, I have that linear demand function highlighted. I've chosen that. That's why you see this one lit up here. Okay. Now notice down at the bottom of this, there is this option. This says display equation on chart. I don't know. Are your eyes still young enough that you can read that? That says display equation on chart. Watch what happens when I click that. Okay, it puts this equation right here. That's the formula for this straight line. Okay, and that's what you do. I've done the same thing up here for the exponential function. And we're going to use this throughout the assignment. That exponential function, that's our demand function, which is saying that here that quantity equals 29,265 to the exponent negative 0.686 times the price. Okay, here, since I have price on the x-axis, x up there is really price. So this is telling me that my demand function is 29,265 then raised to the exponent of negative 0.686 times my price. Okay. You should get that formula. Go ahead and write that down. You're not cheating if you write that down. Did you not do it because you didn't want to cheat?
I,
You want to be like Horowitz.
it's,
That's good. But I'm giving you a free pass
I'm literally
today.
recording this.
Go ahead and write that down. I want you to get that right. And, you know, I'm wanting you to learn about some of the very cool things that Excel will do for you. Okay? All right, any questions about how to fit a trend line or a function, and then how to ask it for the formula for that trend line? See, this is really powerful, because basically what this is doing, you're taking raw data, you're putting it into a chart, and then Excel is finding the statistical analysis for you that works the best. It's basically, you know, you get to see which function fits best, and then you just tell it, okay, give me the formula for that function. That's pretty darn cool. You know, you don't have to do a regression. You don't have to put it all through an exponential function. It does it all for you. That easy. Okay? So any other question on this? So when you turn this in, just do basically this on a spreadsheet and then print that part of the spreadsheet out. It'll probably be 2 or 3 pages that you need to turn in, but that's what you need to do. Okay? Now, if you're doing this on a Mac, and I see some Macs around, you may have to go out and find Solver and do Solver as an add-in. For a little while, it was not included in Excel for Mac. But if you don't have it, you know, it'll be up there under Tools, down here at the bottom, that's where Solver is. Okay. But you may need to put it there if you're using Excel for Mac. Okay, in part 3, you've just developed this, hang on just a second. You've developed this demand schedule where you have these prices here. I think in the question we only ask you at a price of 0, a price of 1, and a price of 2. But I do the whole thing. Just make a little table that looks like this. Notice this formula over here. That formula is simply the demand function that you've just calculated, but now instead of X, it's just a cell reference to this cell for price. Okay? That's all that is. Yes, sir?
A quick question about your scale. So in the table, it's like 1,500 people, it's a survey, it's represented by 30,000. You want us to multiply everything in the table by the same factor?
Yes.
That scale.
Yes. When you look at the instructions, there are some instructions that says the total market is estimated to be 30,000 people, and since we surveyed 59, almost 60, just divide 30,000 by 60, you get 500. And then, so multiply all your numbers by 500, and we think we'll only get 20% of the market, so then multiply whatever you get by 0.2. Yeah, do all of that before you start through these numbers. Okay? All right. Number 4. Now, on number 4, it's just asking you, what if you were charging $1 and then you increased price? What would happen to revenue? So if you just do a little table like this, like you've done before, same formula here. And for revenue, revenue is just price times quantity. So that's all that's going on in these cells here. You can look at this and say, okay, if I charged $1, my revenue would be $14,737. If I charged $1.25, my revenue would go up to $15,519. So that tells me that there's an increase in revenue. And then number 5 asks you, okay, if there's an increase in revenue when you increase price, what does that say about elasticity? Well, given what we learned last week, it indicates that it's inelastic. If you increase price and revenue goes up, you must be in the elastic region. Or in other words, demand is inelastic at a price of $1. Okay? Now, number 6. Number 6 just asks you to calculate the elasticity at, I think, $51 and $2. That's all the question really asks you. And suggests that you do that by increasing price by a penny. So that's what I have here in my chart is a penny there. So I have this 1 cent change in price and the corresponding change in quantity. So over here for elasticity, this formula is just what we saw last week, where it's just the percentage change in quantity over the percentage change in price. Okay? And that's how I get my negative 0.34. Then just do it there at $1 and $2. The $1.46 here, that's something that comes from down here that I just went back in. Because down here, we ask you to calculate where elasticity is unitary, and then I went back and put it in up here. You don't have to do that, I'm just doing it for illustration. All you really have to have are these 3, but again, I do the whole thing. All right, then in 7, we ask you to use solver to find where demand is unitary elastic. Okay, so let me show you how to do that. I have here the same thing we've seen before. My range of prices and my quantity based on the demand function that we calculated back up in 2. And here I have total revenue, which is just price times quantity. So in these cells right here, that's just $1.25, that cell times that cell. That's all that is. Now, again, I knew where this happens, so I put that line in right there, these values. But if I put my, well, you can highlight any cell you want, but you highlight one of those cells there. Then go up here to Tools, and come down here and click on Solver. Okay, and that's the one I was telling you about before, where you may have to go back and ask. And then come over here. Okay, the way Solver works, you just tell it that you want to maximize that value, because you know that total revenue is at its maximum when elasticity is unitary, right? It's one of those relationships we learned before. So if you just tell Solver to maximize that cell, then the way I've got the sheet set up, it's L91. Tell it that you want to maximize it, so you click here on maximum. Solver is really cool because you can tell it to max it, to minimize it, or to set it to some specific value. And then it says by changing the variable in which cells. And here, you just tell it to change the price cell. And then you come down here and click on Solve, and it does iterations until it finds the value for price that will maximize total revenue. That's what Solver will do for you. Okay? So, any questions about how Solver works? Have you seen Solver in 201? Did he teach you about Solver? So you know about it, or about Solver. Okay, very good. So no other questions about that? Then in B, we're basically just asking you to verify what you've done up in A, 7A, where we say just use, a close percentage change, like a penny change, above and below $1.46, and you'll get those numbers. And then in 8, we say, okay, so what price would maximize total revenue? And it's $1.46, or you might round to $1.50 just for convenience. And then in 9, I ask you, okay, if you round to $1.50, how much is that going to cost you? And so you can do these simple calculations. It's gonna cost you less than $6.50. So obviously, you would change price to $1.50. The point here is, you can do the calculation to get it precise, but then you need to step back and kind of ask the common sense question. Do I really want to be charging people $1.46? Or am I better off charging them $1.50? And for the sake of convenience, yes, absolutely. All right, now, part 2, it asks you about cross-price elasticity between the movie ticket price and the concession prices. Okay, that's what part 2 is all about. So you use some of the information you calculated in part 1, and you should be able to create a table that looks like this, where you have the price, and here I have it running from $3 down to 0. Now I have, well, I'm skipping ahead a little bit. For 1, just have the prices, the ticket quantity, the average concession that you get from the data that you're given into, and then do the multiplication so you get the total concession revenue. Then come over and calculate the cross-price elasticity for both, and I know it doesn't say this, but I'm asking you to do it now. Do it both based on average concession revenue and total concession revenue. And if you get it set up like this, it's very easy to do. Just put the formula in there and copy it down. So you have average concession elasticity, total concession elasticity. Notice that they are not the same. And they're not the same because when you do the multiplication to get up to total concession revenue, then the changes are amplified a lot. And that's why I want you to do both, so that you can see the differences between the two. Okay? So that's 1 and 2. Well, in the second part, we ask you to graph it, and it should look like this, where here you have the ticket price now on the vertical axis, and then total concession revenue. This is our proxy for quantity. Put that on the horizontal axis, and your graph should look like that. And then in 3, it asks you if they're substitutes or complements, and because of the negative elasticities, you know that they are complements. Okay? So that's it. Now, usually, when I have a TA, I have a review session, have the TA do a review session. I had a TA lined up and things fell through. So instead, you just had the review session. Okay? Only this time, it was a pretty special review session. I just showed you everything. Okay? So now, hopefully, you know how to do it. Just make sure you're getting these values. If you have any question, come see me. Okay? I'm working on a TA. Don't have one yet, so just come see me. I'll be around tomorrow. There is a study abroad fair, so in the middle of the day, I'll be downstairs in the atrium. If you had if your team was working on it and had a quick question, go ahead and come by there. I'll take them. Okay. All right, any question about the Excel assignment? When you turn this in, print it, make sure that everybody's name is on it and your group number, so it's easy to identify whose it is. Okay. Yes?
Will you go over the group numbers again?